Hello friends, welcome to this video. How are you all? Good, I hope. Okay, so friends, in this video we are going to discuss the different structures of metamorphic rocks. So how many structures metamorphic rocks are having and what are they? Structures are basically decided by mechanical condition and rearrangement of atoms of rocks. Okay, on two things the structure of a rock depends. The first one is the mechanical condition in which it is being made, and the second one is rearrangement or recrystallization of atoms in the rocks. Metamorphic rocks derived by sedimentary rocks are called parametamorphic rocks. Those derived by gravel are called Pacific rocks. Those derived by arenaceous rocks are called semitic rocks, and those derived by argillaceous rocks are called paletic rocks. So the first texture that we are going to study now is cataclastic texture. What is cataclastic texture? Okay, rocks, those are formed under shearing stress. I have already told you what is shearing stress. Stress means force per unit area, and shearing means when the force acts on the surface parallel to the surface of the object or parallel to the surface of the rock, then it is called shearing stress. Rocks formed under shearing stress and in the absence of high temperature have this type of texture. Durable rocks, durable minerals survive from crushing, and less durable ones are powder. Means strong, durable means actually strong minerals survive, and those are not that much strong, they are powdered, they are formed, means they are powdered. Okay, harder rocks are shattered and crushed, forming crust brachia. Okay, harder rocks are shattered, first broken down into pieces, and then crushed means broken down into very fine material, forming crust brachia. That forms the crust brachia. The name of rock is crust brachia. Oh, I have put the inverted comma wrong. Now it is good. Okay, the name of the rock is crust brachia and crust conglomerate also. If the uh, particles are rounded, then it forms conglomerate, and if the particles or the constituents are angular, then it forms crust brachia. Highly crushed fine grained rocks are called myelonites. Since these structures are formed due to catalysis, catalysis means physical weathering, therefore they are having cataclastic structure. Okay, that's why they are having cataclastic structure. The second structure is maculose structure. What is maculose structure? When argillaceous rocks are subjected to contact metamorphism. You all know what is argillaceous. What are argillaceous rocks? They are the rocks, they are made up of fine grains, very fine grains. They are called argillaceous rock. And when they are subjected to contact metamorphism means what is contact metamorphism? In which hot material comes in contact with rocks and make changes in it. That process is called contact metamorphism. Okay, so when when contact metamorphism takes place in the argillaceous rocks, a spotted rock is formed in areas where incomplete recrystallization takes place. This means a rock which have many spots, means having many spots is formed in those areas where incomplete recrystallization takes place. Incomplete uh, rearrangement of atoms takes place. Okay, spots are due to development of bigger crystals within the fine grained ground mass. Okay, when bigger crystals are embedded in the fine grained ground mass, then these spots are formed. For example, andalusite is a big crystal that is embedded in some fine grained ground mass, then the spots are formed because of this andalusite. Such a structure is called maculose structure. These kinds of structure having spots are called maculose structure. Moving ahead towards the third step, which is cystose structure. Cystose structure, this is its diagram. Number 3, number 3. Number 4, number 4th diagram, number 5th and number 5th diagram. Okay, so stay clear. Platy or flaky mineral align in parallel layers. What happens? Platy means plate-like minerals, or flaky means they are basically like plates. Okay, so platy or flaky minerals align in parallel layers. One over other they lie. This parallel arrangement is called foliation. This arrangement of platy minerals one over the other is called foliation. A foliated rock which is coarse grained and is largely composed of flaky and plaky minerals is called schist. So a foliated rock means there are many layers in that rock, and it is largely composed of flaky and platy minerals with many plates, one over other plate lie one over the other, and it is having large crystal also, then the rock is called cyst. Foliation of cyst is called cystosity. Okay, the foliation of cyst is called cystosity. So what is cystose structure? Platy or flaky minerals align in parallel layers. So this kind of structure is called cystose structure. When platy or flaky means plain minerals like plates align one over the other, then in parallel layer, then this structure is called cystose structure. These are the example of it. Cyst is a rock that have a cystose structure, and in this foliation occurs. Foliation means parallel alignment occurs. Okay, parallel arrangement of plates. So this is the diagram for cystose structure. Fourth one is granulose structure. Granulose structure is found in rocks composed of equidimensional minerals like quartz, feldspar. Okay, structure is found in those rocks. Those are having minerals of equal dimensions. I mean, minerals of rocks are having equal dimensions, means equal size, like quartz and feldspar. They are formed by recrystallization of pre-existing rocks under uniform pressure and heat. These structure is formed These structures are formed due to recrystallization of rocks those are existing on this earth from earlier times under when they are subjected to uniform pressure and heat. This structure is also known as saccharoidal structure. Okay, they break through rough surface. When these are broken down, they break through rough surface. The surfaces are rough. Suppose a rock broke into two pieces, so the surface between them will be rough, as they have even grained structure. Because of their even grained structure, they break into rough surface. This is the granulose structure, fourth one. Fifth one is gneiss structure. This starts from G, but it is silent actually. So gneiss structure is a banded structure. See, you can see many bands here. This is the gneiss structure. Many bands are, so you can see here. So this is a banded structure due to alteration of cystose and granulose. Due to alteration of cystose and granulose means dark colored minerals and light colored minerals. Alteration means first there is dark colored mineral, then there is light colored mineral, then there is dark, then there is light. Means after a gap of one. Okay, so it is a banded structure due to alteration of cystose and granulase, due to alteration of dark colored and light colored bands, and is produced by highest grade of metamorphism. The grade of means metamorphism, 80 to 90% metamorphism takes place in this structure. Bands differ in color, texture, composition, etc. Okay, so this structure is called gneiss structure, and you can see the diagram here. Sixth structure is the Horn-Felsic structure. Okay, what is Horn-Felsic structure? This structure is formed due to contact metamorphism. I have already told you contact metamorphism. When igneous bodies come in contact with a rock and cause metamorphism in it, that is called a contact metamorphism. So this structure is formed due to contact metamorphism, and it is formed by equidimensional minerals such as quartz and andesite. Okay, this is U here, Du. Okay, so it is formed by equidimensional minerals. These are formed by equidimensional minerals, minerals having equal dimensions, equal sides, such as quartz and andesite. And the last and the seventh structure is slaty structure. This is also called slaty cleavage. It develops in shales that have undergone slight metamorphism. And those shales which have gone very small metamorphism, in those shales this structure develops. Okay, fine-grained rocks composed of microscopic flakes of mica show slaty structure. Okay, fine-grained rocks, those are having microscopic flakes, I mean very tiny flakes that we can see through a microscope. Those rocks show slaty structure. It is caused due to parallel orientation of flaky minerals. When flaky minerals are arranged parallel to each other, you can see here the flaky minerals are arranged parallel to each other. Okay. And for example of flaky mineral is mica, chlorite, etc. Slaty rocks are split into thin sheets. These rocks can split into very thin sheets. Slaty cleavage may form at any angle to old bedding. This cleavage may form at any angle. The angle between the bedding plane and slaty cleavage may be anything. It may be anything. Okay. It can be greater, it can be smaller, and the slaty cleavage may form at any angle. The slaty cleavage, it may form at any angle to the bedding plane. Means the angle can means it can be formed at any angle to the bedding plane of shale from which rock has been derived. This is the bedding plane of shale. and this is slaty cleavage. It can form at any angle, at this angle also, at this angle also, means any angle. So this structure is called slaty structure. So friends, I hope you like the video. Stay tuned. Thank you.